Okay, let's have problem 51. This is complex truss. For the semi-regular octagonal truss shown below, determine the forces in members A, B, C, D, and E, F by three methods. So because this is a semi-regular octagon, so the sides B, C, C, D, D, E will be equal to X, and A, B, and E, F would be half X over 2. So this angle is 45 degrees. That's the property of an octagon, because the entire angle is 135 degrees. Then same is true with this. So therefore, this span here is x plus, this is x cosine 45, another x cosine 45. So x plus 2x cosine 45, or x plus x square root of 2. Then for the first method, let's put the reactions first. Call that AY. Then summation forces X, obviously this is 60 to the left, and we have RF. Then we consider this section inside AA. So we consider sections forces inside of section AA, and we cut members AB, CD, and EF, the required members, and two more members are cut twice, namely CF and BF. If the member is cut twice, don't mind, because it is still in equilibrium. We put two, they are two force bodies, so they are in equilibrium by itself. So we put arrows that are equal and oppositely directed. So don't mind for the members that are cut twice. So these are the forces inside the cutting section. Then let's extend line of action of AB and CD. So call that point of intersection between CD and AB as L, and between CD and EF as R. So because AY is inside this section, we need AY. So considering the whole system, summation moments about F equals 0. So this is the first method. So we have AY times quantity X plus X square root of 2, then plus 60. Remember our whole system, 60 times X over 2, that's clockwise, then equals 100 times X cosine of 45. This is X cosine 45, just like that, and this. So cancel out X, or don't mind X, you just imagine X is 1, and we can solve AY equal to 16.863 kilonewtons upward. Then we consider forces inside the section AA. We sum up moments about R equals 0 to solve for force on AB. So clockwise positive, so we have SAB times X, quantity X plus X square root of 2, plus AY, which is 16.863 times quantity X plus X square root of 2. So this 60 is also clockwise, this reaction here. So plus 60 times X over 2 plus X sine of 45. This is X sine 45. Then equals 100 times X cosine 45. So those are the forces involved, because SCD and SEF are not involved. They pass through R. So don't mind X, cancel out X, imagine X is 1, then calculate. SAB is equal to negative 17.574 kilonewtons. So SAB is 17.574 kilonewtons compression. Having found SAB, we then sum up moments about L, considering forces inside the cutting section. This time counterclockwise equals 0. So SEF times quantity X plus x square root of 2, then plus 100 times x plus x cosine 45, then plus 60, this 60 here, times x over 2 times x sine 45 equals 0. So cancel out x again, treat x 1, then we can solve SEF equal to negative 100.71 kilonewtons. So stress in EF is 100.71 kilonewtons compression. Now finally for SCD, the best way is to sum up forces horizontal. There are only two forces involved, SCD and 60. So negative SCD minus 60 equals 0, summation forces X. So obviously SCD is negative 60 or SCD is 60 kilonewtons compression. So those are the forces in those members. So this is the best solution, shortest solution in analyzing this problem, but it needs experience and skills. Who knows, that would be the section that should be considered. So I think only few can think of that. So the next method is by method of sections. So we begin with joint C here. You can begin at any point, but the easiest joint is C. So we need the reaction forces first. Summation forces Y to solve for RF. Then we need this angle, theta AE and theta AD. Theta AE is equal to theta BF, and it is also theta CD. Theta AD rather is also equal to this angle here and this angle here, CF. So summation forces Y equals 0. 16.863 plus RF equals 100. So RF is 83.137 kilonewtons. So we begin with joint C. Let's solve for angles first. Tangent theta E is x over 2 divided by x plus x square root of 2. Cancel x. So imagine x is 1. So theta AE is 11.701 degrees, and that is also theta BF or theta FB. Then tangent of theta AD is equal to x over 2 plus x sine 45, x over 2 plus x sine 45 divided by x plus x cosine 45. Cancel x or imagine x is 1. Theta AD, which is equal to theta CF or FC, is 35.264 degrees. And remember, BC and DE makes an angle of 45 degrees with horizontal. So that's it. Then we analyze joint C on the next slide. For joint C, these are the forces and the angles. At C first, these are the forces involved. So we sum up forces vertical first, downward positive, so that we can express SBC in terms of SCF. So SCF sine of 35.264 plus SBC sine of 45 degrees equals 0. Then SBC is equal to negative 0.81649 of Q. 0.81649 of SCF. Then at C, summation forces X equals 0. SCD plus SCF cosine of 35.264 equals SBC, which is negative 1649 of SCF cosine of 45 degrees. So SCD can now be expressed in terms of SCF, negative 0.81649 cosine 45 minus cosine 35.264. So SCD is equal to negative 1.3938 of SCF. Then we proceed to joint D. At D, summation forces Y first equals 0, downward positive. So SDE sine of 45 plus SAD sine of 35.264, then plus 100 equals 0 because downward is treated positive. So call that equation 1. SD sine 45 plus SAD sine 35.264 degrees equals negative 100. Call that equation 1. Summation forces X equals 0. So we have SDE cosine of 45 equals SAD cosine 35.264 plus SCD, and SCD is negative 1.3938 of SCF. Then from equation 1, SAD is negative 100 over sine 35.264. So that would be negative 173.207. Then negative sine 45 SDE divided by sine 35.264 is negative 1.2248 of SDE. So in equation 2, SDE cosine 45 equals SAD. SAD is negative 173.207 minus 1.2248 SDE cosine 35.264, then minus 1.3938 SCF. So we can now express SDE in terms of SCF. So negative 173.207 divided by quantity cosine 45 plus 1.2248 cosine 35.264. So that would be negative 82.842. Then negative 1.3938 SCF divided by quantity cosine 45 plus 1.2248 cosine 35.264. That would be negative 0.81645 SCF. So that is SD in terms of SCF. Then we proceed to joint E. So these are the forces involved. First, summation forces X to express SAE in terms of SCF. Leftward positive. So SAE cosine of 11.701 plus SDE, which is quantity negative 82.842 minus 0.81645 SCF cosine of 45 equals 0. So SAE can be expressed in terms of SCF. So it is positive 0.81645 cosine 45 divided by cosine 11.701. That would be 0.58957 ECF. Then positive 82.842 cosine 45 to the right, positive, divided by cosine 11.701. That would be 59.821. So that is SAE. Summation forces Y at E equals 0. Then we have SDE, which is quantity negative 82.842 minus 0.81645 SCF sine of 45 equals SEF plus SEE, which is quantity 0.58957 SCF plus 59.821 sine of 11.701. So SEF can be expressed in terms of SCF. So negative 0.81645 SCF sine 45 minus 0.58957 ECF sine 11.701. So that would be negative 0.69688 SCF. Then negative 82.842 sine 45. Then minus 59.821 sine 11.701. That would be negative 70.710. So that is SEF. Then we proceed to joint F. So these are the forces involved. Summation forces Y first summation forces X first at F, leftward positive, so that we can express SBF in terms of SCF. So SBF cosine of 11.701 plus SCF cosine of 35.264 equals 0. So SBF is negative 0.83383 SCF. Then summation forces Y equals 0. So SEF, which is quantity negative 0.6968 SCF minus 70.71 plus 83.137 plus SBF, which is plus ECF sine of 35.264, then plus SBF, which is negative 0.83383 SCF sine of 11.701 degrees equals 0. So the only unknown here is SCF. So let's combine SCF negative 0.69688 SCF plus sine 35.264 minus 0.83383 sine 11.701. That would be negative 0.28864 SCF. Then 70.71 minus 83.137 is negative 12.427. From here, we can solve SCF equal to 43.054 kilonewtons. Having found SCF, we can now compute SCD, SEF, but before that, let's proceed to joint B first. So SCD is negative 1.3938 of SCF, and ECF is 43.054, so it is equal to negative 60 kilonewtons, or SCD is 60 kilonewtons compression, just like our answer in the first method. Then SEF is negative 0.69688 of SEF, this one, of SCF, which is 43.054 minus 70.710. So SEF is negative 100.71, or SEF is 100.71 kilonewtons compression, which is the same answer in the first method. Then finally, for SAB, we have to proceed to joint B first. So SBC first is negative 0.81649 of SCF, and it is negative 35.153 kilonewtons. Then we also need SBF. SBF is negative 0.83383 of 43.054, so it is equal to negative 35.900 kilonewtons. So we proceed to joint B. These are the forces involved. Summation forces Y to solve for SAB. So SBC, which is negative 35.153 sine of 45, equals SAB plus SBF negative 35.9 sine of 11.701. So from here we can solve SAB. SAB is equal to 17.576, negative 17.576, or SAB is 17.576 kilonewtons compression. So our answer in the first part is 17.574 kilonewtons, so that is acceptable because of rounding off of values. So they are practically the same, respectively, to our answer in the first method. So that's it for this problem. It's lengthy, but this is the more or less the method that most of the students can think of. The third method is what we call method of substitute member. So this is specially made method for complex trusses. So the idea here is we select a member to be replaced with another member, and the technique is to to transfer or replace that member with another member in such a way that the joint where that member is connected to will have easy calculations or determination of the stresses. For example, at joint C, so we select CF to be the member to be replaced with another member AF. So I transfer CF to AF. The purpose of that, the the advantage of that is at C there's no load, so automatic BC and CD will be zero force members. So that's the advantage. You can actually choose any member from this trust and transfer it to or replace it with another member if you want. There's no restriction to that, but what is important is you have to select a member in such a way that when you remove that or transfer that to another joint, then the forces attached to that joint will be automatically of known force, like at C, so they are automatic zero. Now, to transfer the member, make sure that it will not coincide with another member, because if it will coincide, that's still okay, but you might forget that there will be two members for that if they coincide with that another member. So that's the sad thing. If you coincide that member with another member, you might forget that there are two members attached to those joints. So it's best if you can transfer it to another joints where there is no member present. Actually, you can also substitute CF with DF if you want, but DF is inclined, so the best member would be this member AF because it is horizontal. It's easy to determine the force of a horizontal or vertical member. So again, there's no restriction about substituting the member, but it is advantageous if you replace that member in such a way that the joint where that member is attached to will have no load. If all the joints have loads, then you have nothing to do. You have to select, you have to transfer it to another member, and you have to solve for the forces remained in that joint. So it consists of two phases. In the first phase, we have to solve for the forces of all these members left. Then in the second phase, we apply the force in CF so that all other members can be expressed in terms of that force in CF. Then, because this is the substitute member, this does not exist, the the final bar force of this member should be zero because this doesn't exist. So in other words, the force in member AF in the first phase plus the force of member AF in terms of CF in the second phase must be equal to zero. So from there, you can solve for the force of member CF. Then, since all other members have forces in the first phase added to the force in the second phase, which is in terms of CF, and CF has been found, then you can determine the forces in all other members. So that's the procedure. So let's proceed. So remove CF and substitute that member with member EF. So therefore, there are only two forces at joint C, so these members are zero force members. So we begin with joint D. So remember, that's 35.264. This is 45 degrees. So first phase, SBC is 0 and SCD is 0. At D, summation forces X first to relate SAD in terms of SDE. So SDE cosine of 45 equals SAD cosine of 35.264. So therefore, SAD is equal to negative 0.8602 of SDE. Then summation forces Y at D equals 0, downward positive. SDE sine of 45 plus SAD, which is 0.86602 SDE, sine of 35.264 plus 100 equals 0. So SDE therefore, which is the only unknown here, is negative 100 divided by quantity sine 45 plus 0.8602 sine 35.264. That will give us negative 82.843 kilonewtons. Then SAD is 0.86602 of negative 82.843. So SDAD is negative 71.744 kilonewtons. We then proceed to joint E. These are the forces involved, so that we can solve SAE. Summation forces X first equals 0, leftward positive. So SAE cosine of 11.701 plus SDE, which is negative 82.840 cosine of 45 equals 0. So we can solve SAE. 82.840 cosine 45 divided by cosine 11.701, and that is positive 59.822 kilonewtons. Then summation forces vertical equals 0. So we have SDE, which is negative 82.843 sine 45 equals SEF plus SAE, which is 59.822 sine of 11.701. So SEF is negative 70.711 kilonewtons. Having found SEF, we proceed to joint F. These are the forces involved. Summation forces Y first to solve for SBF at F. So we have SBF sine of 11.701 degrees plus SEF, which is negative 70.711 plus 83.137 equals 0. So SBF is 70.711 minus 83.137 divided by sine 11.701, that's negative 61.271 kilonewtons. And finally, summation forces X at F equals 0 to solve for SAF. So SAF, leftward positive, SAF plus SBF is negative 61.271 cosine 11.701 equals 0. So SAF is equal to 59.998 kilonewtons. Then since we need AB, we proceed to joint B first. These are the forces involved. Remember that is 0. Summation forces Y equals 0 at B. Then downward positive. So SAB plus SBF, which is negative 61.271 sine of 11.701 equals 0. So SAB is 12.426 kilonewtons. So it is a good practice if you check if joint B is in equilibrium. Summation forces X 60 plus SBF, which is negative 61.271 cosine of 11.701. That should be equal to 0 or almost equal to 0. So if that is true, then it means that all these answers are correct. All these values are correct. So that's it. This is the first phase. Then let's proceed to the second phase. So the second phase, as I said, is you remove all the loads and reactions, then apply the remove member, which is CF, express that or denote that as Q, then all other members should be expressed in terms of that force, SCF. So this is it. So this is SCF. Then let's denote that as Q. Then we will express all these members, especially CD, AB, and EF in terms of Q. So that AF also in terms of Q. So that the idea is, remember, AF does not exist in the original truss. So the final bar force of AF should be 0. So this is the first phase value. The second phase value of AF will be in terms of Q. Then add, equate to 0. Then you can solve for Q, which is the force in CF. Then that is also true for the other members. The final bar force is force in the first phase plus force in the second phase. That's it. So we begin at joint C. Summation forces Y equals 0 first. So these are the forces involved. So S BC sine of 45 plus Q sine of 35.264. This is 35.264 equals 0. So SBC is, in terms of Q, is negative 0.81649 Q. Remember, Q is SEF. Then summation forces X equals 0. SED plus Q cosine of 35.264 equals SBC, which is quantity negative 0.81649 Q cosine of 45. So SCD can now be expressed in terms of Q, negative 0.81649 Q cosine 45 minus cosine 35.264. That would be negative 1.3938 of Q. Then we proceed to joint D. Those are the forces involved. Summation forces, vertical first, to relate SAD in terms of SDE. Downward positive. So SDE sine of 45 plus SAD sine of 35.264 equals 0. So SAD is negative sine 45 or sine 35.264. That's negative 1.2248 of SDE. Then summation forces X at D equals 0. So we have SDE cosine of 45 equals SAD, which is negative 1.2248, SDE cosine of 35.264 plus SCD, and SCD is negative 1.3938 of Q. So we can now solve or express SDE in terms of Q. Negative 1.3938 Q divided by quantity cosine 45 plus 1.2248 cosine 35.264. So SDE is negative 0.81645 of Q. Then SAD is negative 1.2248 of negative 0.81645 of Q. So SAD is Q also. So that's it. Let's proceed to the next slide. Then we will put the values of SBC, SCD, SAD, SDE in terms of Q. So that will be guided. So from the preceding slide, these are the forces in terms of Q so far. So we now proceed to joint E. These are the forces involved. First, summation forces X so that we can express SAE in terms of Q. Leftward positive. So SAE cosine of 11.701 plus quantity negative 0.81645 Q cosine of 45 equals 0. So SAE can now be expressed in terms of Q. It is 0.81645 Q cosine 45 over cosine 11.701. So it is positive 0.58957 of Q. Then summation forces Y to express SEF in terms of Q. So we have negative 0.81645 Q sine of 45 equals SEF plus SEE, which is 0.58957 Q sine of 11.701. So SEF is negative 0.81645 Q sine 45 minus 0.58957 Q sine 11.701. So SEF is negative 0.69688 of Q. Then we proceed to joint F. These are the forces involved. Summation forces X equals 0. Leftward Y first equals 0 to solve for SBF in terms of Q. So SBF sine of 11.701 plus Q sine of 35.264 equal plus SEF, which is quantity negative 0.69688 Q, equals 0. So SBF is 0.69688 Q minus sine 35.264 of Q, then divided by sine 11.701, that would be 0.58941 of Q. So that is SBF. Then summation forces X equals 0, leftward positive, so that we can now express SAF in terms of Q. So SAF plus SBF, which is 0.58491 Q cosine of 11.701 plus Q cosine of 35.264 degrees equals 0. So SEF is negative cosine 35.264 minus 0.58941 cosine of 11.701. So SAF is negative 1.3937 of Q. So we have expressed SAF in terms of Q. We have AB left. So we proceed to joint B, summation forces vertical or y equals 0 to solve for SAB in terms of Q. So negative 0.81649 Q sine of 45 equals SAB plus SBF, which is 0.58941 Q sine of 11.701. So SAB is negative 0.81649 sine 45 minus 0.58941 sine 11.701. So that's negative 0.69688 of Q. Then again, perform checking. Summation forces X should be 0 so that we can validate all our answers here to be correct. So summation forces X equals negative point equals SBF 0.58941 Q cosine 11.701 plus negative 0.81649 Q cosine of 45, and if you combine, that's almost 0, so okay. So that means all our values, all calculated values in terms of Q are correct. Then we recall the forces in CD, AB, EF, and AF in the first space. So remember that CD was 0, then EF is negative 70.711, AB was 12.426, and AF was 59.998, if you can recall, kilonewtons. Then the second phase values are there. So let's tabulate. We have member, force in kilonewton in the first phase, force in kilonewtons in the second phase, then the final bar force here. So let's begin with AF because AF does not exist. So remember, EF does not exist, so its final bar force should be 0. In the first phase, it was 59.998. In the second phase, the negative 1.397 of Q or negative 1.397 of SCF. Then final, you add the two, should be 0. So in other words, 59.998 plus negative 1.3937 Q equals 0. So from here, we can solve Q, which is the force in CF, which is 43.049 kilonewtons. Then for member AB, the first phase is 12.426. The second phase is negative 0.69688 of Q. Then this is the final force. In other words, SAB is 12.415 plus negative 0.69688 of Q, which is 43.049. That's the final bar force. And that is equal to negative 17.574, which is the same as before. So therefore, SAB is 17.574 kilonewtons compression. Same answer in the first part. Then CD. CD, first phase, 0. Second phase, negative 1.3938 of Q. So the final bar force should be 0 plus negative 1.3938 of 43.049, and that is equal to negative 60.002. Our answer in the first phase and second phase was negative 60. So that's tolerable. That's the same. So it is 60 kilonewtons compression. And finally, for member EF, first phase is negative 70.711. Second phase is SEF, negative 0.69688 of Q. Then this is the final bar force, negative 70.712. Then negative 0.69688 of 43.049. And that is equal to negative 101.71, which is the same answer in the first solution and the second solution and the third solution. So it is 100.71 kilonewtons compression. So that's it. I hope that you learned techniques in analyzing trusses. So the best way I think is the best solution is the second method, because that's the thing that most of the students can think of, the solution by method of joint. You just go around, then from one joint to another, then you can find out that you can answer the problem. For the first technique, that's rare solution. For the third technique, by method of substitute member, that is specially made for complex trusses, and you can do that. However, the solution is lengthy because it involves two phases of solution. Now, only the members involved are tabulated here. You can actually compute the forces in all other members. They are part of the solution if all members in this complex truss are required. So that's it, and I hope that you learned something.